What does that change? Okay, brilliant. Sweet. Are we all good, Ricardo, for me to start?
Yep,
Okay.
you can go
Okay,
for it.
sweet. Firstly, yeah, thank you everyone for joining. For those of you that haven't met me, my name's Shaq. I work inside the Kubernetes service, in the platforms and infrastructure team in the IT department. Today I'm going to be giving a brief overview of some work that we've been working on in the Kubernetes team. This is still like very early stage, so like any feedback is welcome. And yeah, I guess if you have any questions as we go along, like either post them in the chat or we can talk about at the end. I'm just going to give a brief overview of the work we've done and then give a basic demo of how the backup and recovery process works for what we have set up in the Kubernetes service. In terms of what we're actually going to focus on is specifically cold recoveries. We're not looking into like active or active passive setups because yeah, I mean it's a lot more complicated. And I guess as with most software engineering, start with the simplest stuff first and then work up in complexity. So if that is something that people are interested in, then we can look into that at a later date. Yeah, great. So let's get started. So as I'm sure you're aware, like backup is becoming increasingly important to the CERN IT department, and I hope I don't need to convince anyone of the importance of having these systems in place and why they're so valuable. One thing to stress is that in the Kubernetes service, the clusters that you deploy as part of this are not backed up by default. Like it's your responsibility as a user to set up, manage, and configure these disaster recovery protocols. As I'm going to explain in the rest of the talk, like we have the tooling integrated into the Kubernetes service for you to easily do this. There's APIs that I'm going to go through that will explain how to get all this stuff set up, but it is more so on you to make sure that you've got these things set up properly. One thing that I think I personally want to emphasize the importance of based on work I've done in previous projects outside of CERN is that it is incredibly important to actually exercise disaster recovery and not just do it once a year, but being comfortable with the fact that many different people in this team, in your team, are prepared to recover from a disaster because having one person that knows how to do it with the credentials often isn't enough. I've provided a link to, it's maybe 7 years ago now, but it's quite an interesting story of an issue that happened at GitLab where they're running a Postgres database for their main service and they actually have a active passive setup. So you would have thought that they were in a very good place to recover from a disaster, but in short, what happened, the database that they were running for their primary services was accidentally deleted. And when they then went to recover from the backups that they were recording, they found that the actual clients that they were using were incompatible. So because they'd upgraded their version of Postgres and the client that they were using to store the backups, none of the backups had been working since they'd done this upgrade. So they were then put in a very difficult position to yeah, kind of recover. And I think obviously you'd rather solve these things when production isn't down. So I think exercising it is very important. I think one thing that you get as a side benefit of this is the two bullet points we provided on the slide is that if you're comfortable that you can easily pick up one service from one cluster to the other and drop it into another, it then becomes very easy to do cluster migrations, specifically in Kubernetes. So things like cluster upgrades become a lot less painful and a lot less scary because if you're moving a service from A to B and when you move it into B, it doesn't work properly, then you can revert back to A and you kind of regroup and revisit these things. And then the second point is like being able to transfer data from one environment down. At my previous company, this is something that we were required to do so we could do load testing with like the level of data that was in production. So we'd kind of pull anonymized data from our production to our staging environments, and using tooling like this makes it very easy to do so. So I guess the first question for people that are familiar with Kubernetes is why can't I just back up etcd? Etcd is the underlying database that Kubernetes uses to keep track of what's deployed on what node with what configuration. So this is basically the backend database. Etcd does by default offer support. There's a command line tool that you can use to back up the state of your cluster, but this isn't particularly user-friendly for various reasons. It requires that you have access to the master node that Kubernetes API is running on, which particularly if you're deploying in a public cloud, you often don't have access to the control plane. This is abstracted away. But then it also requires that your cluster is healthy for you to be able to pull the backups and restore the state of your cluster. So if everything's been completely wiped and your cluster's been completely deleted, it's not possible for you to restore completely from backup. And I think probably a more important point is like this messing around with etcd and configuring things in the master node is typically like an admin level operation, and ideally you'd want to delegate the management of backups as far down in the chain. So typically, like, users should be able to do this. And in my opinion, like, going into etcd and doing these backups is not really a feasible one. etcd also is only going to back up the actual resources that are included in the cluster, which is great if you're running a stateless application. But if you're storing things in persistent volumes and this data itself isn't going to be backed up, etcd will back up the fact that there's a pointer to a certain persistent volume, but the actual underlying data, which is often important stuff, it isn't going to be backed up. And I think if you're running like in a fully GitOps managed environment, then restoring the actual resource state of your cluster is typically very easy because you have Argo, you have Flux to manage all these things for you. So the process of recovering from just that purely stateless application being deleted, it isn't too difficult. It's the restoring your persistent data, which is typically the challenge. And this is where the tooling that I'm going to talk about for the rest of the presentation is very useful. And then I think one other important thing with etcd is that, like, the backups are by definition imperative. Like, you need to go into the master node and run these backups for them to be run on for them to be run at all. Whereas ideally you'd want them to be run in an automated fashion on a schedule where you can kind of set it and then hopefully forget about it. Yeah, so the tooling that we have decided at CERN for the Kubernetes service to resolve this is called Velero. Velero is one of the projects that sits in the CNCF, and it's a tool for managing backups. It does the backups of the cluster resources, which, as I mentioned, would have been previously covered by etcd, but then it also will back up the underlying data in your persistent volumes. This data is then typically transferred to an external cloud provider, an S3 bucket, Google Cloud Storage bucket, for example. And so even if the cluster gets completely deleted, it's then very easy for you to restore from backup. You just need access to that S3 bucket where you're storing your data. Importantly, backups are also, because Velero is running inside of your cluster, everything is managed as a Kubernetes resource. So things like triggering backups and restores can either be done through a CLI that Velero provides, or you can create a kind of custom resource that I have a snippet of I can show you later on. But essentially, you can define a backup and say, I want you to back up these resources at these times. And then when you do the restoration operation, you can point to that backup. One thing this allows you to do is means that your backups can be tracked in Git and approved in the same way. So, like, if I need to do a restoration operation, it's not just one person roguely running commands against a cluster, which often when things are going wrong is very easy to make a mistake, whereas you kind of introduce this peer review process back into that. And yeah, I guess most importantly, it means you don't need to interact with etcd. Like, you can, as a user, it's then very easy to manage backups and restores. You don't have these complications with shedding into nodes and these difficulties. So as I mentioned, this is a very, like, obviously scaled down version of what actually happens under the hood, but Velero is running inside your cluster. I trigger a backup using this command here, Velero create backup, the name of the backup, and then I want to wait. And this essentially will then, the command will hang until the backup is either completed or failed for various reasons. What Velero is then doing is it's then contacting the Kube API server to pull this information from etcd. And this is then transferred to a storage bucket or cloud storage provider of your choice. Assume that then cluster one on the left-hand side is completely deleted. This isn't an issue because then all I can do is I can bootstrap a second cluster. And as long as I've got Velero installed and Velero has access to this storage bucket, then I can essentially restore everything from the backup I've previously created, which is, yeah, pretty great. So how do I get started with this? It's fairly easy. Velero offers a Helm chart, which you can install and you can configure everything in a similar way. But the way that we have this set up at CERN is it's been included in the umbrella Helm chart that gets released as part of when you deploy a cluster at CERN. So what I've provided on the screen here is basically a example of the things that you need to provide to get everything set up. So you need to provide an S3 bucket, which is where your data gets uploaded to, and then you need to provide the credentials to access that bucket. The bucket you need to create ahead of time before you then create your cluster. And I guess the important thing is that these credentials here, this S3 access key and S3 secret key, these are credentials. So like this, like YAML snippet, typically you wouldn't want to, or you shouldn't commit it to your version control for obvious reasons. So yeah, I provide this snippet and then I run the OpenStack command and pass in this YAML snippet. And what it will do is, in addition to deploying the services that you'd normally enable, it will deploy Valero, which deploys two extra components into the kubesystem namespace. It deploys the Valero server, which is responsible for talking to and from the Kubernetes API and managing the creation of backups, etc. And then it deploys another component which basically hosts file system modules for transferring the persistent volume data from your node to the external storage. So I will give a demo at the end of this presentation, and I can show you in a little bit more detail what these things are and how they work essentially. But yeah, essentially, once you've got this deployed, the process of then backing up a stateless application is very easy. You just need to run like this command I provided before, like out of the box, everything will work by default. If you want to configure the backup of persistent volumes, there is a little bit more extra work that you need to go through, but it's fairly simple, and I will explain shortly. So in terms of how backing up persistent volumes works, there's two options for this. One of them is using volume snapshotting, which is, is there a question? Okay, yeah, perfect. Cheers, Ricardo. Is using the Kubernetes offers a volume snapshotting as part of the default machinery that comes with your cluster. And what this allows you to do is basically take point-in-time snapshots of a persistent volume, which is where all your data is being hosted. And so, yeah, this is one option. This is the option that we recommend. There is another option that allows you to essentially just point to the PVC and back up from there. This isn't recommended because essentially you don't have a point-in-time snapshot of what's going on. Like your backup can be running and there can be applications writing to and from the persistent volume. So it is then very easy to get into a situation where you have incomplete backups or things don't point to correctly. And so, yeah, as I mentioned, the approach we recommend is using this volume snapshotting, which is currently like partially supported. It will really depend on the storage types that you're using at CERN, or the storage types that you're using in the cloud. In the cloud, it's a lot easier because all of the storage types provided in the cloud typically support these volume snapshotting. But specifically, this table here outlines the storage types that we've tested on. So we initially focused on CephFS and Cinder. There's multiple CephFS clusters at CERN. Some of them have snapshotting enabled and some of them don't. For you to make use of this, you'd need to be using a cluster that has snapshotting enabled, which would be the Marin CephFS-B cluster. As I mentioned, this is currently not flagged as being production ready, but yeah, I guess like the purpose of this talk is to disseminate the information, and then we can go through the process of iterating on the work that we've done, and I guess increasing the support of this if this is tooling that is useful for everyone. Yeah. So yeah, partially cover this. As I mentioned, we recommend using snapshotting because it ensures that your backups can be point in time. It's then very easy to recover without having like these incomplete transactions, for example. But in terms of what's actually happening under the hood when you're backing up a persistent volume, Valero is delegating a lot of this work to the CSI driver, the container storage interface. This is a default thing in Kubernetes, which is responsible for managing all different types of storage operations. And it was introduced, I'm not sure how many years ago now, but it essentially solves the problem of integrating lots of different storage types into Kubernetes without relying on the Kubernetes like repo to like handle all the integrations for Azure, GCP, OpenShift, etc. Like you can delegate that to other people that can maintain these, and then essentially creates like a pluggable interface. So say I have a persistent volume and I want to back it up, all I need to be able to do is, firstly, it needs to be backed by a CSI driver that supports this snapshotting, and then I just need to annotate the persistent volume claim with the details of the relevant volume snapshot class to use. So I have a toy example that I'll show at the end, which will kind of hopefully clear any of this up if it's unclear at the moment, because I appreciate there's lots of different concepts going on. But in terms of like how the backup process actually works for PVC, this is a scaled down version of what's actually happening under the hood. And I've kind of abstracted things away, so it's maybe not totally correct, but it will show the general flow of what gets created throughout the process when a backup is running. And then obviously this will happen in the inverse when you're running a restore. So yeah, same situation as before. I want to trigger a backup. I can do this using the Valero command line. This sends a request to the Valero server, which will then start processing my resources. When it then hits on a resource that needs to be backed up using this PVC handling, essentially this node agent will delegate the CSI driver. The CSI driver is able to speak to my PVC that I'm backing up. So in this case, my cluster has one PVC. It has the MySQL-PVC. What the CSI driver will then do under instructions of these two Valero components is create a snapshot of the PVC. So this will be a point in time. This is what was going on at 8 a.m. in the cluster when my backup was triggered. And so what this allows everything to happen is essentially I don't need to pause any writes. Like my cluster can carry on as normal using MySQL, and my backup from 8 a.m. will still be valid and atomic and ACID and all these other terms that are incredibly important when we're running database style transactions. So yes, the snapshot is created. What Valero will then do is it will create a copy of the PVC that's being backed up from this snapshot. So this is the point in time at 8 a.m. And then the Valero node agent can use a choice of two different tools, either Copier or Restic, for transferring the data from the PVC to the cloud. So Copier and Restic, I believe, both support this kind of incremental backup. So if I'm backing up 1 gig, that first gig backup is a gig. And if I then only wrote a few megabytes, the next backup will be only a few megabytes. I think one thing to consider with this, obviously, the more data that you're backing up in the PVC, the slower your backups will happen. And you'll see, I'll give a demo shortly. The backup of the stateless workload is typically very quick, but then because there's this need for the provisioning of snapshots and then another PVC that is using this data, it is a little bit slower. But yeah, I mean, this is essentially how it works. And then obviously the process of restoring will kind of trace this diagram basically in the opposite direction to provision a resource from the data that's stored in S3. So yeah, that was an overview of, I guess, essentially the PVC backup and the stateless backup, but Valero does support a lot of other features that are quite nice. I mean, I think one of the most important ones is the scheduling. This is something that you obviously wouldn't be able to do in etcd without any like complicated scripting. It's not natively supported, but essentially I can define a schedule. I can say I want you to back up these namespaces, these resources on these schedules, and yeah, it's delegated to the Valero component to handle these backups. One thing that I can do is I can then obviously set up alerting and monitoring for if a backup fails for any reason. I can get a Grafana alert or Prometheus alert manager alert that will notify me that my backup hasn't worked for obvious reasons. And yeah, like this is one of the things that in the GitHub, in the GitLab Postgres thing I mentioned at the start of the presentation, like this kind of alerting thing wasn't in place or it wasn't working, so they weren't even aware that they didn't have any backups. So having this kind of regulating that every day your backups run okay, I guess gives you a little bit of comfort in the fact that things are working all okay. The other thing that's quite useful about the Valero CLI is you don't just have to back up everything. I can back up specific things. I can, in this little green command here, I can select specific namespaces. So for whatever reason, I only need to back up 2 things, then this is what I can do. I think this thing is particularly useful if I want to start transferring resources from one namespace to the other or one cluster to the other with these kind of environment hydration scenarios that I mentioned at the start of the presentation. Equally, I can choose to exclude things from a backup if, for whatever given reason, let's say I'm running Redis and as a cache, I may not want to bother backing up that data because it's cached data and it doesn't really matter if I lose it. Things like this are very useful if you then want to start improving the speed of how backups work, which is useful. And yeah, so one of the other, I guess, big selling points of the Valero tool that I've mentioned is essentially being able to use it as a cluster migration tool. And this is because it is able to handle persistent volume data. The idea is that clusters become slightly more ephemeral and it's a lot easier to transfer between environments. In Kubernetes, there's kind of this concept of cluster as cattle, which is essentially making things as disposable as possible, not getting tied into one cluster that we can never touch, we can never move. But being able to move things from clusters gives you a great amount of flexibility, particularly when you're running upgrades of the Kubernetes API server. I mean, it doesn't really happen so much anymore, but Kubernetes previously, there was lots of big breaking changes that would be introduced that your cluster upgrade may run perfectly fine, but like they've changed the name of what a resource should be from one thing to the other. And then your deployments don't work in the same way without you needing to kind of amend and correct all of these things. But being able to spin up a cluster B of prod environment, upgrade this to the latest version, and then transfer your production applications from the cluster running the old Kubernetes version to the new one, you can then validate that everything works fine. And if it does brilliant, you can then bin the old cluster and carry on as normal. But if it doesn't, then you can just go back to running your previous production environment in the old Kubernetes API and then kind of revisit what you need to do to be able to run this upgrade. So what this allows you to do is it kind of takes away a lot of the risk of running these in-place cluster upgrades, because you have a backup, right? You can just revert back to where you were previously, and there's maybe no harm done. Brilliant. So I guess that was kind of a brief overview of everything in Valero. This is a, I guess, public service announcement, and then I'll give a brief demo. But this is essentially the gold standard for backups, is the 3-2-1 rule, which is essentially that for everything, you have 3 copies of it. You have your production copy and ideally 2 replicas that are split across 2 different mediums with one on off-site. So what this means is that if for any number of reasons, like a whole data center goes down or a whole specific storage type is affected for whatever reason, then you have this resilience. Obviously, getting this kind of set up requires effort and it is expensive to store these multiple copies over different environments. But I think this is what ideally people should aim for, and then I guess we can slowly get there. And I think obviously in some cases it's not always possible, but like this is ideally where we should be aiming for the maximum level of resilience if you're kind of choosing to do this only cold recovery scenario. I think one thing that's maybe important to stress is like there needs to be some level of understanding of actually where your backups are stored and how the underlying infrastructure is being run, because if you're backing up data in one cluster to another service that is still being deployed in the same cluster. So I give an example here of a Ceph cluster. I'm not sure that this is the case at CERN, but in some scenarios, that Ceph cluster could be running both Manila and S3. So if I'm backing up a Manila share to S3, yes, it's on technically a different medium, but it's backed by the same underlying resource. So if that Ceph cluster goes down for whatever reason, then I'm losing both my storage and my backups. So I just think this is one thing to think about when planning how you approach disaster recovery is, am I actually resilient? Have I actually distributed each of my eggs evenly across the basket so that if one is dropped, I'm not screwed? Yeah. So I maybe pause for questions now, and then I can give brief demo. I don't know if there has been any questions in the chat at all, Ricardo. Can't. No, okay.
I don't see any right now, so feel free to come forward if you have any questions. Otherwise, go ahead with the demo and maybe people will come up with them after.
Okay, sure, that sounds good. So I guess the source code for this I've just posted on a personal GitLab repo if people are interested, but they're fairly like toy examples with just basic bash scripts, but hopefully it should exercise my point neatly. So I just want to check, is the sizing okay? Can everyone read what's on the screen? I guess if not, maybe say now, otherwise I'll assume the sizing's all fine. Okay, cool, brilliant. So as I mentioned before, like you need this S3 bucket where everything's going to. So I've just, on LX Plus, I've just happened to be showing these are the buckets that I've got for my demo clusters. I have 3 S3 buckets that are unique for each cluster. So I have no issues with cross-pollination of data. But so in terms of what actually gets deployed when I enable Valero in the Kubernetes service, there's these 2 pods, as I mentioned before. There's a CERN Magnum Valero, which is the core Valero server that's responsible for managing all of these different backup operations. And then there's the node agent, which is only used by Valero when I'm doing a backup of a PVC. So if you have a multi-node cluster, what you will see is there'll be one Valero server, and then there'll be one node agent per node because it's deployed as a daemon set. This is required because PVC will live on a specific node, so the thing that's responsible for backing up and transferring the data needs to be on the same node as well. It's just one thing to be aware of. In terms of what I'm going to do for my demo is I have a MySQL database running with just some toy data, and I'm going to give a basic example of just showing how you can move it from one namespace to the other. And this will show, yeah, how the restore process works. So in terms of what this looks like, I have a namespace, I have a service that exposes it, I have a persistent volume claim where I define my underlying snapshot, my underlying storage class, which is CephFS. As mentioned, this is the testing instance where snapshot is enabled. And then what I annotate my PVC with is the volume snapshot class. So this is essentially telling this volume snapshot class stores information about the CSI driver. So what Valero can then do is it sees that I want to back up the persistent volume. It knows what volume snapshot class to do, and then it knows which CSI driver to essentially tell it to do the work. And then the rest of the deployment is just a basic MySQL deployment that's done rather insecurely, but for the purpose of this demo, it will work. Let me just copy and paste from another slide. So all I have deployed in this database is just mock data with the users table. What this is then stored in is it's stored in a share in Manila. So if I just switch back to the other terminal, I can just show you OpenStack share list. This data is then being stored in this persistent volume claim here. So it's got 4 gigabytes of data, and all of my information should be encased in here. So in terms of, I've just installed Valero, I've configured everything. Now that I need to do is trigger a backup. And so the way that this is done is through using either this can be done, as I mentioned, as a Kubernetes like YAML manifest resource, but for now I'm just going to demo with the CLI from Valero just because it's a little bit easier. So what I do is I specify that I want to create a backup, I give it a name. For this purposes and just for speed, I'm only backing up the MySQL namespace, which is where I've deployed this MySQL deployment. This will just make things hopefully a bit quicker for the demo. And then I specify this -- wait flag. And what this will do is it essentially creates one of these like, I'll just run it and show you. This creates like a little loading bar, which should show the status of my backup. So Valero is kind of under the hood. It will initially start by backing up the resource, like details that are in etcd, and then it will go through this process of backing up the PVCs to the workflow that I described previously. This may take about 30 seconds, so we'll just let it go. But what will happen, and I think one important thing to note is that if you're backing up PVCs, what this will require is that you have at least double the quota in your OpenStack project, because it is creating this second PVC that's a copy. So just one thing to be aware about: if you've got 5 gigabytes of data or 50 or 100 or whatever, you need double the amount of available quota so that when this backup is running, it has space to provision a new PVC. So if I was to, let's see if it's doing it yet. Oh, that's not very easy to read. So yeah, you can see previously there was only one PVC with 4 gigabytes, whereas now there's currently 2. And you can see that this is marked as being created from snapshot. So yeah, Valero is maybe about 75% way through the process. This snapshot's already been created. I'm now creating my copy PVC, which will then be used to transfer my underlying, mock users table from my cluster to the S3 bucket. And yeah, I guess just while this is going, one thing that we specify by default, which isn't enabled by default in the Valero Helm chart, is that we essentially ask it to transfer the data from the cluster to the GCP bucket, or not GCP, but whatever storage bucket you're moving things to. This isn't turned on by default. So what would by default happen is that Valero will trigger a snapshot, and this snapshot will live in the cluster. And then what gets backed up is the fact that a snapshot exists in Valero, but not the actual underlying content. And the reason why we decided not to kind of change this option is because if somebody accidentally deletes that Kubernetes cluster that I want to then restore, then it's also going to delete the snapshot. So I want to move my data from being in just the production environment to my production environment and a replica. Right, so hopefully this is finished now. Nope, okay. I'll let it go. Okay. I guess while this is running, is there any questions? Thomas, I have one. Is
Hey,
anyone looking?
yeah, I just, can you hear me?
Yeah.
Yeah. Hey, thanks. Very interesting presentation and the demo is very nice. So I was wondering if you talk with I guess mainly the database people, is there a way to use Velero with NetApp and that support NetApp snapshot? Is it something you plan to investigate in the future?
So this is something that I can investigate in the future. It's not something that I've looked in so far. I think it is one thing that is on the backlog, but we just haven't got around to doing it yet. In theory, like if the NetApp CSI driver supports this snapshotting, then it should be possible using the same workflow as what I'm hopefully is going to work as what I'm demoing here. It seems to be taking quite a long time.
Okay. Yeah, because for us it would be necessary. So maybe we can collaborate as well on that and share the testing. That would be interesting. Thanks.
Yeah, that sounds good. Is there any other questions while this is going?
If I may, have you tried this with an active instance while the instance is some kind of benchmarking tool running some queries and then transactions? And also, have you tried to restore from the active instance in in this situation?
Yeah, I can answer both of those. For the second question, in terms of the restore process, like yes, we've gone through testing of specifically with a Vault instance where I'm essentially assume the Vault instance has been deleted in one test, and then I want to completely do cold recovery. And they've also done another attempt where Vault's still running and just the underlying PVC that's backing it has been deleted. The results from this kind of vary in terms of success because Velero by default or it will basically do this non-destructive restore. So if the thing already exists in the namespace, it's not going to try and overwrite it, which I guess is smart. But I think for things like PVCs, what we found most effective is that you are essentially restoring into a fresh cluster so that you don't have this issue of conflicting resources. And what should happen under the hood is that a PVC is provisioned with a copy of the data in the new cluster. In terms of the sorry, carry on.
Yeah, no, I just wanted to say because normally when you rely on a backup taken as a snapshot, it's a good practice to use some functions which will put the database in some kind of backup mode, let's say so. So
Yes.
there is some protection from having a snapshot which is not consistent enough, let's say so. So
Yes.
because I haven't seen any place where you invoke these functions, I wanted to know, how does it work behind the scene?
Yeah, that's fair. Yeah, I completely agree with what you're saying in terms of this kind of read-only mode, it sounds like, but in terms of like it's Velero doesn't have responsibility or delegation powers over the application, so it's not easy for it to trigger it putting in an application into this read-only mode if the application even supports it. So I guess one thing to bear in mind, as you pointed out, is that if there is things that are in memory that haven't yet been written to disk or written to the PVC, then this is lost from your backups.
Yeah, it's basically like the restore will be in a situation like where there was a crash, basically, and then
Yes.
Okay, I understand.
I think one of the things that I guess Velero have taken in their design philosophy in terms of how they built this is assuming that your application is set up in a way that maybe it can recover from these if they're is things that have been incompletely restored, or like there's only details of a transaction that haven't been fully written, is yeah, what I would say, I guess. In terms of your first question, which you asked, in terms of the load testing, we haven't done this at a big scale in terms of how like efficient it is in terms of the backups running while there's a heavy write load. As you can see from the length of time that this took, it probably took almost a minute to back up everything. So I think much of this time would have been a process where it was provisioning a snapshot and then moving that data to the PVC, etc. So yeah, I think this is something that we as a team maybe need to investigate at a much larger scale, because I would expect what is it look like for most people is that backups are taking of order of hours, depending on the amount of data that it is that they're backing up. For things like stateless applications, it's very quick. Yeah, so I hope that answers your question. I'll just maybe continue with the demo if there is
Yeah,
anything more.
absolutely.
Okay, lovely, thank you. So yeah, as you can see, provided this dash wait flag is dropped out all these dots while everything's running, what it then gives you is an overview of what's essentially happened. So if I run this command here, I can see that my backup is marked as complete. I can see how long it's taken. So yeah, it took, well, significantly longer than a minute. It took almost 6 minutes, it looks like. It gives me details of things that have been backed up and whether the data has been moved or not. There is a similar command for showing the logs from the Valero server. I'm not going to show that because it's not the easiest thing to read. But in terms of if I then go back to S3 in LX Plus, I can just give a brief overview of what the actual, what do they call Valero? Sorry, I can't see with a zoom. That's just stupid. So this is my bucket. You can have multiple different applications backing up to the same bucket. It's possible to namespace things. Like for the purposes of simplification of the demo, I've just assumed one bucket per cluster. But yeah, there's two things that have been written to the bucket now. There's details of the backups, which will contain essentially the contents of etcd, which is all of my resources in my cluster. Give it one more, MySQL demo. Oh, yeah, spelling mistake. Right, so here's everything: volume snapshot classes, my logs, my pods, etc. The second folder contains the actual underlying PVC data. So if I'm using copier as the underlying backend, it will be called copier. Similar thing for Restic. These are stored separately for some reason. I guess it's just a small quirk of yeah, essentially how Valero works. But I will trigger the restore operation now, and then while that runs in the background, I can maybe answer any questions because it looks like it might take a while. So yeah, script, same process. For the purposes of demo and simplification, I'm just backing it up into a different namespace in the same cluster just to keep everything simple. As I mentioned into one of the questions, what we did typically when testing is assume cluster A had been deleted and I need to completely do a cold restore on cluster B. So I'm just creating a new namespace, MySQL restore. I then specify the backup name. So this is MySQL demo, and then I can specify a mapping from, I want to map everything that was previously deployed in MySQL into MySQL restore. So just let this go. And yeah, similar process, provide the dash wait flag and it will go. What this will then do is kind of go through that backup process in reverse, obviously. Yeah, so I guess, I don't know, maybe is there any more questions in terms of while we wait for this to go rather than sitting in silence?
Hi, Jack. Thanks a lot for presentation. I think I had the question that I posted. I think Thomas basically replied to me, but I was wondering if there was a native way to encrypt the backup with Valero. But I mean, I think with hooks, as suggested Thomas, probably is the best way. I don't know if you had any experience with that.
So personally, no, we haven't looked into this yet. I think, as Thomas has mentioned, there's a plugin that supports this, but by default, the backups are not encrypted, as I'm sure you're aware based on the question, I guess. In terms of how the hooks work, so this isn't something that I've explored personally, but we can look into it as a team and then maybe add this to the documentation, so it's a little bit more clear on how to get these things set up if that is a use case for you.
Yeah, just my reply was more for how you would like freeze your application with hooks to do
Oh,
specific
okay.
to measure. But I think the other thing to look at is RESTIC support encryption. So probably it will be more on the RESTIC or Copia side that you would look at encryption. But I didn't look at all at it either on our side, so I don't know yet. But it's certainly something that we need to have a look at a point if we want to have secure backups.
Okay. Yeah, that makes sense. Thank you, Thomas. Yeah, I
Yeah.
can follow up on that, Antonio.
But there is support. You can pass an encryption key, and RESTIC will take it. I haven't done it with Copia, but for RESTIC it should work.
Okay. And then, yeah, so similar process, like it was a lot quicker for some reason. I don't know why the previous one was so slow. But essentially my backup's been marked as complete. So what I should see now is if I list out all pods, I now have a copy of the MySQL database in this second namespace. And if I shell into it, it should have the contents of that dummy S3 table, not S3, users table that I demoed earlier. So MySQL restore, yeah, that looks correct. Yeah, so yeah, all my information's there. It's been moved from one PVC to the other, and what you'll see in OpenStack is that I have a completely actually I'll just show you instead of talking. I have a completely new PVC that contains this data. So all of the ones that are 4 GB. So this would have been the previous one, and this is the copy that's been created from my snapshot. And so what Kubernetes is doing is then just mounting that once. So Valero is able to trigger that in the same way because we have these OpenStack integrations set up within the cluster. That was everything I had in terms of demo and presentation. I don't know if there's any more questions. Failing that, I will upload the slides to the Indico link, which contains pointers to both Valero's documentation and our also internal documentation for getting this set up inside clusters that are deployed as part of the Kubernetes service.
I have maybe one thing, because you mentioned in the demo you use the commands. You mentioned that this in underneath are Kubernetes resources.
Yeah.
Do you have an example, or maybe it created in the cluster while you're doing the restore or something? Do they stick
Oh yeah,
there?
I can show that actually. I was going to pull up the docs, but yeah, that's probably easier just to show in cluster if I just is it going to change screen? There we go. So the Valero CLI does support like this retrieval of backups as well, but these are Kubernetes resources, so system. Oh yeah, maybe I'll just explain all of them, right? So there's a backup storage location, which is a custom resource that Valero sets up. This is your storage bucket, which is S3, AWS S3, CERN S3, whatever. There's a backup and then there's the equivalent restore. So I list it here. You see I get the same information as what I'm getting from using this Valero CLI. Valero CLI has obviously a little bit more information, but what I can then do is that's a bit easier. Yeah, so it's fairly similar to what I showed in the previous presentation with the scheduling in terms of what gets set. Like the schedule, I guess, is the same way it works for like a cron job in Kubernetes. It just wraps around this. So I'm specifying how long I want to take to move the data to and from one cluster to the other, which namespaces to include or exclude, whether to do this kind of transfer of the volume snapshot data from the cluster to the other, which storage bucket to use. So I do kget kube. Oh, come on. Maybe default. So this is the bucket that Valero creates when you provision your cluster using so Magnum. I provide like the details to the bucket, and you can see this points to Valero demo 1, which is the bucket that I was previously listing everything out for you. Then obviously the credentials for that are stored as a Kubernetes secret. They're not pasted in the YAML here, but yeah, I don't know. Does that answer your question, Ricardo, in terms of how
Yeah,
everything looks?
it was just to also like give the idea that a lot of this, the ones you showed are kind of retrieving information, but you can also declare things using GitOps just as Kubernetes resources without
Yeah.
necessarily like doing the Valero command. So you can just put it all in your repo and work with that. Like I think you mentioned that at some point that like for a restore you could have like someone reviewing it and the proper cycle.
Yeah, I think this is just from previous experience, like people, especially when there's an issue in production, people are prone to making mistakes that then make things worse. So like having the restore operation as part of a pull request review means that you'd hope at least one other person is looking at it and giving it a sense check.
I was just gonna add something also for the question before from Thomas about NetApp. So we do have the integration with NFS, with CSI NFS, but it's the generic CSI driver. So it doesn't do any kind of fancy snapshotting because that's not in the spec. But there are vendor-specific CSI drivers that offer that functionality on top. We have not looked at the NetApp one, but it's a possibility. And then this would just hook into Valero transparently somehow. So to be tested, but it should do it.
Yeah, this is my hope. I looked at the CSI driver of NetApp, and this seems that it should be trivial. But yeah, I was wondering if it's something we likely want to test in the next weeks, months. So we'll see. We'll come back with some results at a point.
Yeah. Don't know if other people have other questions. This is the time. We're 45 minutes in, so otherwise, yeah, we can thank Jack for awesome presentation. And if you have any questions, you know where we listen. So either in the chat or Snow, just reach out. And Jack will be happy to follow it up.
Yeah, of course. Sounds good.
Yeah. Thanks, Jack.
Yeah, no worries. Thanks for joining, everyone. Much appreciated.
Thank you, Jack. Bye.
Cheers.